Welcome to the Math Museum by Youngjun, Sungyoon, and Hyunmin. Our standard is find common factors and multiples and use the distributive property to rewrite them. And our standard in our own words are rewrite common factors and multiples with distributive property. Now you may ask, what is distributive property? Well, distributive property is a property which multiplies each addend separately, then adding the products together. As you can see, 4 comes from multiplying 4 and 1, because distributive property is multiplying each addend separately. 4 times 1 is 4. 4 times 3 is 12. Now we've got 4 and 12. These are the products. Now we have to add the products together, which is 16. Now on to factors and multiples. Factors are numbers that make up a specific number using multiplication. For example, 4. If we choose 4 as a specific number, then we have the factors here: 1, 2, and 4. The definition says numbers that make up a specific number, which is 4, using multiplication. So 1 times 4 is 4. 2 times 2 is 4. So there is your factors for 4. Multiples are numbers that are multiplied by the specific number and another number. In this example, the specific number is 4. The specific number and another number, which is 1 or 2 or 3 or 4, are multiplied together to make up the multiple. Now let's see. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 is a multiple of 4. 8 is a multiple of 4. 12 is a multiple of 4. 16 is a multiple of 4. And it keeps going. On the next 2 slides, I will show you what is GCF and how to solve it, and what is LCM and how to solve it. GCF stands for greatest common factor. It means the greatest common factor of 2 different numbers. For this example, I chose 4 and 8. Now let's see. 4's factors are 1, 2, and 4. 8's factors are 1, 2, 4, and 8. But since GCF stands for greatest common factor, the greatest common factor is 4 in this case. Now let's try 4. Let's make that standing out. Let's try with a method usually used for GCF and LCM and distributive property. What you have to do is put the 2 numbers you chose, 4 and 8 in this case. So 4 and 8, it doesn't matter what order you do. And let's just make this clear. 4 times 1 is 4. 4 times 2 is 8. Now, you could do this in a lot of different ways, because if you factor out 2 first, you get 2.
then you can factor out once again, which is 4 again. So these will be the GCF because it's the greatest common factor, and it also works by writing the numbers down and circling the greatest factor.
On this side, I will show you how to solve LCM. LCM stands for least common multiple, and it's not factors, it's multiples. As you can see, I wrote down 4's multiples and 8's multiples. As you can see, I wrote down 4's multiples and 8's multiples. 4's multiples are 4, 8, 12, and 16. 8's multiples are 8, 16, 24, and 32. Since LCM stands for least common multiple, the least common multiple is 8, right here. 4 times 2 is 8. 8 times 1 is 8. Now let's use the usual method to solve LCM. I've got the two specific numbers, 4 and 8, and so I got 4, 1, and 2 from 4 times 1 and 4 times 2. 4 times 1 is 4, and 4 times 2 is 8. GCF, we only needed this number, but in LCM, we need to multiply all three numbers here, which is 8. 8 is the LCM of 4 and 8. As you can see, it has the same answer as the one written here and the one method I used to solve LCM.
On this slide, I will show you how to find the area of a rectangle using distributive property. We know that this side is 3 inches, this side is 1 inch, and this side is 4 inches. In this rectangle, there is 1 inch and 3 inches. In this rectangle, there is 4 inches and 3 inches. Both rectangles have 3 inches in common. So, to use distributive property, we multiply the common number with the two addends. Addends are numbers you add together. So, 3 times 1 is 3. 3 times 4 is 12. 3 plus 12 is 15. So the area of this rectangle is 15 inches squared. Now we know how to solve distributive properties, but let's see how it ties in with common factors and multiples.
This slide will explain how to rewrite common factors and multiples using distributive property. As the specific number, I chose 14 and 28. The numbers I wrote here are 14, 1, and 2. 14 times 1 is 14. 14 times 2 is 28. Now let's change this into a distributive property. 14 goes here. 1 and 2 goes here. As you can see, 1 and 2 are the addends. And wow, we already solved it into a distributive property. Now let's check if we're right. 14 times 1 is 14, and 14 times 2 is 28. We are right. A real-life example of LCM. On a special party, every 12th guest gets an iPhone 6. Every 36th guest receives a 3D TV, and every 72nd guest gets a touchscreen watch. Which guest will receive all three gifts first? Because the problem says first, we have to find the least, and this is the LCM. Now let's use our LCM skills to solve this problem.
First we got 12, then we got 36, then we got 72. Okay, let's write 12 here. 12 times 1 is 12. 12 times 3 is 36. And 12 times 6 is 72. I explained that LCM, we multiply all these numbers here. So, let's multiply. 12 times 1 times 3 times 6, which is 216. So the 216th guest receives all the gifts: iPhone 6, 3D TV, and the touchscreen watch. A real-life example of distributive property is Max bought 3 boxes of apples and pears. Each apple box has 26 apples and each pear box has 35 pears. Each apple costs $1 and each pear costs $1.5. How much money did Max spend? Now let's see. Apples and pears. One apple costs $1, so there's 26 apples in one box. $1 times 26 is $26 in one box. Pears. Each pear costs $1.5 and there's 35 pears in one box. 1.5 times 35 is 52.5. So $52.5 for each pear box. There is 3 boxes of each apples and pear boxes. So let's use distributive property. 3 times 26 is 78 and 3 times 52.5 is 157.5. Now you may ask, where did this 26 and 52.5 come from? Well, it's the cost of each apple box and each pear box. So 3 times 26, 78. 3 times 52.5 is 157.5. Together it is $1,235.5. So the cost is $0.5 for everything. So that's how much Max spent. We as a group used to think distributive property was only a fast calculating method, but now we think it has a bigger role. We now believe distributive property is a method to rewrite common factors and multiples.